Look at the moon. Beyond it, hidden in the shadows of our solar system, are millions of flying rocks. To most, they are just debris, but to the world's first trillionaire, they are the ultimate gold mine. We are standing at the edge of a revolution that will make the internet look like a footnote in history. Earth is running out of time. The rare minerals that power your smartphone, your electric car, and the AI chips of tomorrow are disappearing. Supply chains are breaking. Geopolitical wars are brewing over the last scraps of our planet's resources. But what if I told you that a single asteroid, floating just a few million miles away, contains more platinum than humanity has mined in 10,000 years? In 2026, this is no longer a dream. NASA, SpaceX, and a handful of secretive startups are already launching the hardware to capture these cosmic treasures. We are moving from a planet of scarcity to a galaxy of unlimited abundance. This is the dawn of the $100 trillion economy. This is the era of asteroid mining. In this deep dive, we reveal the technology, the trillions, and the terrifying risks of the greatest gold rush in human history. Welcome back to AU Mines. Let's head into the belt, the Psyche.
Imagine a rock. It's roughly 200 kilometers wide, drifting silently in the darkness between Mars and Jupiter. To a casual observer, it's just debris. But to an economist, it is a 10,000 quadrillion fortune. This is 16 Psyche. If we could somehow tow this single asteroid into Earth's orbit and mine its iron, nickel, and gold, the sheer volume of wealth would collapse every stock market on the planet. For the first time in human history, we are on the verge of ending scarcity forever. Right now, we are entering the year 2026, and the space industry is no longer about small steps for man. It is about the largest industrial revolution since the invention of the steam engine. We are transitioning from a planet-bound species to a galactic economic power. But how do we reach these riches? Who gets to own them? And what happens to the global economy when gold becomes as common as industrial steel? To understand why we must mine the stars, we first have to look at the crisis unfolding on Earth. Our modern world runs on a very specific set of materials, rare earth elements: neodymium, terbium, and dysprosium. These aren't just names in a textbook. They are the heart of your smartphone, the magnets in every electric vehicle, and the guidance systems of advanced defense technology. Currently, a single nation, China, controls nearly 90% of the world's refined rare earth supply. This creates a massive strategic bottleneck. In a world of rising geopolitical tensions, relying on a single source for the backbone of our technology is a risk the West can no longer take. But the problem goes deeper than politics. We are simply running out of high-grade ore. Traditional mining is becoming deeper, more expensive, and more environmentally destructive. This is where the near-Earth asteroids, or NEAs, come into play. Astronomers have identified over 30,000 NEAs, and thousands of them are rich in platinum group metals. A single 500-meter-wide asteroid can contain more platinum than has ever been mined in all of human history. Companies like Asteroid, based in California, have already launched test missions to prove that we can refine material in deep space. They aren't looking for gold, they are looking for the materials that will build the next century of human technology. If you control the platinum, you control the future of energy and computing. But how do you actually mine a rock moving at 20 kilometers per second in a zero-gravity environment? This is where the engineering becomes mind-bending. Traditional mining relies on gravity to keep machines on the ground. On an asteroid, gravity is almost non-existent. If a robot tries to drill into the surface, the force of the drill will simply push the robot away into space. In 2026, we are seeing three revolutionary solutions. First is optical mining. Pioneered by TransAstra, this method uses giant inflatable mirrors to concentrate sunlight onto the asteroid's surface. The intense heat causes the rock to fracture and release water vapor and gases, which are then captured in a giant bag. Second is the robotic swarm approach. Instead of one large machine, we send hundreds of small, multi-legged robots like the SCARE. These robots use specialized gecko-inspired grippers or microspines to lock themselves onto the jagged surface. They work together like an ant colony, grinding the surface and moving material to a central refinery. Third, and perhaps most importantly, is in situ resource utilization, or ISRU. We cannot afford to bring fuel from Earth. It's too heavy and too expensive.
Instead, we mine the asteroid for water ice. By splitting water into hydrogen and oxygen, we create rocket fuel in space. This turns asteroids into cosmic gas stations. Once we have fuel in orbit, the cost of space travel drops by 90%. This is the key that unlocks the rest of the solar system. Let's talk about the money. The first company or nation to successfully return a significant amount of space minerals will trigger an economic shockwave. Platinum is currently worth about $30,000 per kilogram. If a mission brings back 100 tons, the price will plummet. While this sounds like a disaster for mining companies, it is a miracle for industry. Cheap platinum means fuel cells become affordable for every home. It means a revolution in chemistry and manufacturing. But there is a dark side to this gold rush. Who owns an asteroid? The 1967 Outer Space Treaty states that outer space is not subject to national appropriation by claim of sovereignty. In plain English, nobody can own the moon or an asteroid. However, the United States passed the Space Act in 2015, which says that while you can't own the asteroid itself, you can own the resources you extract from it. China and Russia are challenging this view, leading to a new era of space law disputes. We are seeing the formation of safety zones under the Artemis Accords, which critics argue is just a polite way of saying, "This is our mine, stay away." We are witnessing the birth of space capitalism, and the stakes couldn't be higher. The first trillionaire on Earth won't be a software developer, they will be the person who masters the logistics of the asteroid belt.
Asteroid mining represents more than just profit. It represents the end of the zero-sum game. For all of human history, if one person had a piece of gold, another person didn't. Resources were finite. But space is infinite. By moving our heaviest and dirtiest industries off-planet, we can protect Earth's environment while providing limitless energy and materials for a growing civilization. We are the generation that will see the first made-in-space products. We are the generation that will see the first lunar and asteroid refineries. The $100 trillion economy is waiting for us, 240,000 miles away and beyond. Should space resources belong to all of humanity or to those who are brave enough to go get them? Let me know in the comments below. The era of scarcity is ending, and the era of abundance is just beginning. At AU Mines, we don't just watch the future happen. We decode the technologies and economies that are building it. If you want to be a part of this journey to the stars, you're in the right place. Don't forget to subscribe and hit that notification bell so you never miss a deep dive into the $100 trillion space economy. If you found this video valuable, give it a like. It tells the algorithm that science and technology matter. And check out our previous video on lunar mining to see how this cosmic gold rush first began. The galaxy is open for business. The question is, are you ready? I'm Marcus, and we'll see you in the next orbit.